So I've got a 165-inch rod that's leaning up against a wall, right? And maybe it's laying down kind of flat. Maybe it's like really vertical. The point is, it's always 165 inches long on a diagonal. And it's sliding until eventually it'll be just laying flat on the ground. And it looks like the height here, which I'm going to label H, it looks like that's changing at some rate, 2 inches per second. So that statement, the vertical distance between the top of the rod and the floor is decreasing at a rate of 2 inches per second, is code for the statement that dh dt equals -2, assuming we call it h. Maybe you call it y because you like vertical things to be y. I don't care. So that's code. Now, they're asking a question here, and they're asking how fast is the horizontal distance between the bottom of the rod and the base of the wall changing. That's code for asking dx dt equals question mark, where I haven't told you what x is, but we're going to make it up right now. That distance down there is going to be x. And there's a motion arrow going in that direction, and it's dx dt. And the motion arrow that I have unlabeled on the h-axis is dh dt. And my unknown is that value there, dx dt, it's my unknown. From these two things right here, I see that my variables are going to be h and x. So in step 2, when I relate, I'm going to relate x and h. I'm going to relate x and h by using, again, the Pythagorean theorem because I've got a right triangle. In this case, I have that x squared plus h squared equals 165 squared. And even though I know that the vertical distance here is 153 at some particular time, I'm not going to substitute it in yet because otherwise I'll accidentally get 0 for my derivatives because that wouldn't be true at all times. This is true at all times, regardless of how fast things are moving. And from it, once I differentiate with respect to time, I'll have that d dt of x squared plus d dt of h squared equals, I'm just going to put a 0 on the right-hand side because it's just 165 squared. So I have 2x times dx dt plus 2h times dh dt equals 0. Cancel some 2's, move an x to the other side, and we'll have that h times dh dt equals minus x times dx dt. It's got this really nice relationship between h, dh dt, x, and dx dt. Ooh, so we should substitute now. Okay, for substitute. So let's substitute. My relationship is h times h prime equals minus x times x prime. Maybe you like primes. I just wanted to throw those in there. Maybe you like dots. I really like dots because those dots indicate time derivatives to me. I have some physics background. Right? So I need h, dh dt, x, and dx dt. I need those values. I'm trying to find dx dt. That's my unknown. X, we have to go back to the statement of the problem. It says the vertical distance is 153, so h is 100, dh dt is -2, so then x, how am I going to get x? We're going to use our friend the Pythagorean theorem once again. And so x is going to be the square root of 165 squared minus 153 squared by the Pythagorean theorem. So I know everything but one value, right? I know everything but one value. So now I'm going to solve. What am I going to solve? I'm going to solve minus 2 times 153 equals minus the square root of 165 squared minus 153 squared. times dx dt. So then 2 times 153 over the square root of 165 squared minus 153 squared equals dx dt. I'm trying to really explicitly show you the 5 steps. I practice these 5 steps. This is how these problems go for me. I think they really work. I do note that Newton if there's common factors in integers and things like that, it really wants you to cancel common factors. So I was working with some students earlier this week, and we found that Newton was marking answers that were actually technically correct as incorrect if you weren't canceling common factors. So it wants them to be in simplified form. So I kind of like it when they just want us to put in floating point numbers, because then I don't have to deal with that. That was particularly in answers that dealt with pi.